Hello, my name is Junwoo Park and I'm a student at Korea International School. And today I'll be presenting on examining the spatial heterogeneity of cancer incidences by cancer types in Korea. Here's the table of contents. Now, a quick background story about me. All four of my grandparents on both my mother's and my father's side had cancer. And both of my grandfathers, they both passed away because of the cancer that they had. And that made me question for multiple years now. Why was it them that got cancer? Why did they get cancer? And why did they have to go through this suffering? And that's been my motivation and my leading question for the past few years until this moment of presenting my research to you. So let's get right into the background information. Cancer has been identified as the leading cause of mortality for over 3 decades now in South Korea, and the number of cancer cases in Korea has been on a consistent increase. In 2009, the number was 196,000 cases of cancer, while in 2023 that increased to 227,000 cases. The etiology of cancer involves both genetic predispositions and environmental factors, meaning we have to approach this from an interdisciplinary approach. You have to look at multiple factors at the same time. And hence, there is a need to understand the importance of geographic health disparity research for cancer prevention. Yes, in the status quo, there are medical approaches or biological approaches as to how to treat cancer, as how to cure cancer when someone already got it. But environmental factors and geographic health disparity research are a necessity for cancer prevention in the long term, right? How to prevent cancer, that is determined through environmental factors. Now, there were numerous studies in the past that did analyze this environmental factor relationship with cancer incidences. For example, in 2018, there was a study that identified rural-urban disparities and their research and their relationship to cancer types and cancer rates. In 2014, there was a study that focused on high urbanization and population density's effect on lung cancer incidences. But the commonality between all of these previous studies is that first, there were very few studies on cancer incidences in Korea within the field of environmental planning. Second, there were no studies at all to explore the association between spatial variation and cancer types. Thirdly, there were very few studies incorporating official measured cancer data at the local level. In South Korea, it's at the Si-gun-gu level. Now, my entire research centers around the first law of geography by Waldo Tobler in 1970. He states that everything is related to everything else, but near things are more related than distant things. Therefore, I have three main concepts that is involved in my research conceptual diagram. First, geographic determinants, second, health disparity, and thirdly, cancer incidences. All three factors continuously affect one another and leading to a chain reaction consistently changing and is dependent on one another. Hence, my research question is, what are the effects of spatial variation on different types of cancer incidences in South Korea? My research will obviously be focused within South Korea, but more specifically at the Si-gun-gu level, at the more local government. Now, the data used in my research will be from 2014 to 2018, a span of 5 years. And this is because the South Korean government releases their cancer data at a time interval of every 5 years, which is also why I wasn't able to use more recent data, because at the time of doing my research, the more recent 5 years, the data for them has not been released. And of course, I will be covering the 6 most prominent cancer types in South Korea: breast cancer, colorectal cancer, hepatocellular cancer, lung cancer, prostate cancer, and stomach cancer. As for methodology, I used a software called IYRC to do spatial analysis to analyze what types of cancer are most prevalent in what region specifically, and how much of a prevalence that is compared to other regions, spatial analysis. I also used correlation analysis to find out the relationship between different cancer types as well as different environmental factors and how strong of a relationship that is. For example, if breast cancer is most prevalent, how does that affect hepatocellular cancer? That is something I'll explain later of this presentation. Now let's dive right into results. As you can see, all 6 types of cancers are very prevalent in South Korea, with stomach cancer being the most prevalent. And let's look at the maps that I created using ArcGIS. As you can see, the different types of cancers are differently distributed across the nation. For example, breast cancer incidences are mostly focused around the Seoul metropolitan areas. Colorectal cancer is more widely spread out, but is focused mostly around the central region of South Korea, while hepatocellular cancer are mostly distributed across the southern and eastern regions of Korea along the ocean side. Lung cancer, once again, is around the central region of South Korea, and prostate cancer is more evenly distributed across the nation. And stomach cancer, once again, is mostly centered around the central regions of South Korea. Now, in my study, I used the Moran's I-value test to determine whether or not the spatial autocorrelation for all these cancer types are whether or not they exist, whether or not they're statistically significant. And any Moran's I-value of under 1 is something that is statistically significant, which is the case for all 6 types of cancer. For lung, hepatocellular, colorectal, breast, prostate, and stomach cancer, they all have significant spatial autocorrelations shown through the Moran's I test. Which is why I decided to do the local indicators of spatial association, otherwise called the LISA analysis, to analyze the clustering of different cancer types. If you look at these graphs here, the red or the high to high clustering indicates regions with high number of cancer incidences being placed right next to other regions of high cancer incidences. The blue regions, or the low to low clustering areas, are regions with a low amount of cancer incidences being placed in close proximity to other regions with low rates of cancer incidences. And as you can see, once again, they differ for each type of cancer. Right? Breast cancer has the high to high clustering, or the red regions, at the north, while the colorectal cancer, on the other hand, also has it at the north, but hepatocellular cancer has it in the southern and eastern regions of Korea. So they all differ, right? The clustering of cancer types differ based off what cancer type that is. There are significant amounts of variations, and that difference is statistically significant. Now let's look at the results. As for the correlation or the relationship between different cancer types, as you can see, all relationships between all forms of cancer are shown to be statistically significant. But if you take a look at hepatocellular cancer and breast cancer, they have the strongest negative correlation out of all these relationships. So this leads us to our conclusions. 2 main conclusions, 2 main findings from this research. First, there was consistent clustering of cancer incident rates in specific regions varying by cancer types. Meaning, the clustering was different for each and every one of cancer types, right? There are very statistically significant differences. But second, the study showed high positive and negative correlations between different types of cancer. Once again, variation, it differs depending on what type of cancer that is. So let's talk about how this has implications on our future policies. First, it proves the necessity for targeted strategies for each cancer type. Because each cancer type differs so much in what regions they are most prevalent in and what forms of clustering they have, there needs to be targeted strategies for each and every one of them. But second, cancer prevention policies must happen at the local government at the region-specific level. In South Korea, like I mentioned, it needs to happen at the Sigungu level instead of the national level. This is because, for example, as we already saw, breast cancer happens most prevalent in Seoul metropolitan areas. Meaning, in Seoul metropolitan areas, in that local government, they need to focus their policies on breast cancer. Local governments in the southern eastern areas of Korea, around the ocean side, they need to focus their policies on hepatocellular cancer, because hepatocellular cancer happens most prevalently in those regions. There needs to be policies made at the local government level, at the region-specific level, not at the national level. Let's talk about limitations. What was my research unable to do? I was unable to research into the causation of clustering. What caused these cancer types to be clustered in that specific region for each and every one of them? Right? And this is a topic that I want to research in the future. When I go to a university, when I become a college student, I really wish to be able to research further into the topic on the causation of clustering. I also want to look at this from an interdisciplinary approach, right? Not just in general what causes clustering, but rather more specifically the economic determinants, the social determinants, and the environmental determinants of clustering. You know, how do economic factors such as income disparities, how do social determinants such as urbanization affect it? Environmental factors, how do they cause clustering of certain cancer types? Those are all topics that I want to really wish to research in the future in the future when I have more abilities and when I have more data available to me. Thank you.